Hello class, we're going to be doing a couple problems using applications where we get to use our knowledge of exponents and logarithms to solve the problem that's being represented. So let's take a look at this very first problem. In this problem, we have something that says medical research indicates that the risk of having a car accident increases exponentially as the concentration of alcohol in the blood increases. Now this risk is modeled by an equation, and they give us the equation. R equals 6e raised to the 12.77x, where x is the blood alcohol concentration, and R, given as a percent, is the risk of having a car accident. What blood alcohol concentration corresponds to a 7% risk of a car accident? Well, 7% is going to be the R. And so when R is 7, we want to know what is X. So we're going to take this information, we're going to take this R is equal to 7, and we're going to plug it into this formula for R. So we're going to have 7 equals 6e raised to the 12.77x. And we need to find X. What is that? So I need to get that alone. First thing I'm going to do is divide the equation by 6, because that will cancel that out. So I've gotten something less than that. So now this is e, and if I take the natural log of both sides of this, I would have the natural log of 7/6 is equal to the natural log of e raised to the 12.77x. Well, the natural log of e raised to this, I can just take those out and set it equal to the 12.77x. So I have the natural log of 7/6 is equal to 12.77x. So I'm going to divide each side of the equation by 12.77. So that's the natural log of 7/6 divided by 12.77. And that's going to give me my X value. So I'm going to use a calculator for this, and you can either set it up as a fraction, or remember that the fraction is a division. So the natural log of 7/6, make sure you close the parentheses, divided by 12.77, and you'll find that the blood alcohol concentration, X, is 0.012. So the next problem we have is how long to the nearest tenth of a year will it take $1,000 to grow to $3,600 at an annual interest rate of 8%, compounded quarterly. Now we have a couple formulas for when we're having interest rates. One is A equals P times E raised to the RT, and one was A equals P times 1 plus R over N, and that quantity raised to the NT. Now this one was when it was compounded continuously, and the other one is when it's compounded periodically. And so we need to determine which one of these are we going to use. Since it's compounded quarterly, that means we're going to use this one. So let's determine all of our variables. We have A, and A is the ending amount. Well, that's the 3,600. And we have P, which is the principal amount. That's 1,000. And we have the rate. Well, that's 8%. And we're going to put that as a decimal, 0.08. And we have, not R, we already have R. Sorry, oops, there we go. And T is the time in years. Oh, well, that's what they're asking us for. So that's our big question mark. And we have N, which is compounded quarterly. So that's 4 times a year. So n is 4. So let's build this equation. 3,600 equals 1,000 times 1 plus 0.08 over 4 raised to 4t. All right, we got to get that t all by itself. So the first thing I am going to do is divide by 1,000. And 3,600 divided by 1,000 gives me 3.6. And that's going to be, and you know what I'm going to do here? I'm going to use my calculator and find out what that is. There's no variables in there, so I can get it just a single number. 1 plus 0.08 over 4 is 1.02 as a decimal, and that's being raised to the 4t. So I'm going to write this as a logarithmic equation. So this is my base, 1.02. So I'm going to go log of base 1.02. And then the argument will be 3.6. And that's going to equal 4t. So I'm going to divide each side of the equation by 4 to get t all by itself. So in the calculator, I am going to write log of 1.02 of 3.6 over 4. Now, if you have a TI-84, you can use math, and then you choose option A, and you can fill these in. You know, the 102 and the 3.6. If you don't, you'll have to use change of base. And what you would type in the calculator then would be log of 3.6 divided by log 1.02. And I would put those in parentheses and then divide by 4. Either way you do it, you'll get the same thing, and we're rounding to the nearest tenth of a year, and you're going to find that it takes 16.2 years.